We're restarting our sessions. I'd like to welcome Patrick Woodhead from Protocol Labs. Patrick's going to be speaking about Filecoin Retrieval markets. And I think this is going to be a really interesting talk. So Patrick, you have the floor. Go ahead.
Great, thanks. Should I share my own screen? How's it working?
Feel free to. Feel free to.
Okay, 1 second. Let me just find presentation. Here we go. Okay, can you see my screen? And is it full screen for everyone?
Yeah, all good.
Nice. So yeah, my name is Patrick Woodhead. I am the program manager for the Retrieval Markets Working Group at Protocol Labs. It sits in the research and development department. So we look at stuff at all levels of the research to development spectrum. And yeah, we're going to begin by just talking about what the Filecoin Retrieval market is. We're then going to go on to where we are now. And we'll look at after where we are now, which is kind of, yeah, look at the state of the retrieval market at the moment. We'll look at what we want to get to, like the future state example, where we're aiming for. And then towards the end, we'll look at the Retrieval Market Working Group, which is a collection of ecosystem teams, network teams who are working in this space. And then we can have a Q&A at the end. Also, feel free to, if you like, raise your hand. Hopefully I'll be able to notice and we can take questions as we go. So yeah, I'll begin by just describing what the retrieval market is and motivating the topic. So let's just begin by looking at the internet. The internet is like a road network with traffic jams and crowded roads. And so in order to get content quickly, it's got to be stored near to the end user. To compare it to a more real world example, when you order a book off Amazon, you don't fetch it from where the publisher made that book or where it's initially stored. It comes from some distribution center which is nearby your home, so that they only have to drive a short distance to drop that book off at your place, and it can be done very quickly. And the same can be said for the internet. When you fetch files from the internet, you don't always fetch it from the origin server. You fetch it from what's called a point of presence, which will be a data center nearby your location. And these points of presence, they sit in what's called a CDN, a content delivery network or content distribution network. I think both definitions apply. And as we can see here on the right-hand side, we've got a kind of a topology, like a classic topology of a CDN. You've got like an origin server, and then you've got CDNs which connect to that origin server, and then you have individual users who can fetch files, content from their local CDN. For those who are aware of CDNs, the household names are CloudFront, Cloudflare, Akamai, Fastly. And these Web2 CDNs, they aim to achieve an average of like 25 milliseconds for a retrieval around the globe. But obviously this average is concentrated on retrievals in big cities, and it's got a long tail for more sparsely populated geographies, which we'll come to in a second. One more thing to mention here is that Web2 cloud providers separate the pricing of file storage from file retrieval. So when you upload a file to, say, Amazon S3, you're paying for the privilege of being able to store that file. But also when you then want to retrieve that file from S3, you pay per retrieval. And if you then want to put a CloudFront distribution in front of your S3 bucket, you'll pay extra for that as well to have the super fast retrieval. And that's this sort of separation of the markets of storage and retrieval is something which one doesn't expect when they first think about this. I feel when I speak to people, they assume you store stuff and then retrieval is kind of a given if you've actually stored that object. But that's not so much the case. And actually, it's expected that by 2025, the global CDN market, so retrieving stuff, is expected to be twice as large as the actual cloud object storage market, so storing it in the first place. And when you actually think about that in more depth, it does kind of make sense, because storing a file, you just need to store it in one location, whereas retrieving the file, you have to have this global network of data centers and points of presence, which are enabling users to fetch those files very, very quickly. So I'm now going to attempt to try and poke some holes into Web2 CDNs, because to motivate why we need a Web3 CDN, and in particular, why Filecoin is a good place to build a decentralized CDN. So here we have on the left-hand side, we have Web2 CDN performance worldwide at average time to first byte. And you can see that there's some, clocking in the top, you've got Azure at sort of 22 milliseconds. And going down to the bottom, it's pretty concentrated up to like 30 milliseconds. But if we then look in Africa, you can see that actually it's much, much slower across the board. And actually it's got a longer tail as well. But here, I think we're still seeing like quite condensed data. This is still focusing on a lot of retrievals that are made in big cities. And if we look at this table here, I hope you can see it all. You can see that there's actually a lot of geographies around the world and countries around the world which don't have a single point of presence in a Web2 CDN. So some of these are islands and perhaps it's not necessary, but others are quite big land masses. And we could be looking at some, quite big times to actually fetch files from such land masses. Like, for example, Central African Republic, we've got Greenland, got Sudan, so some quite big areas. And so we got to question why that is. It's probably because these CDNs, a point of presence is actually quite a big undertaking to lay one down. You have to make sure that the physical layer of the network of the internet is there and it's got a really stable electricity supply. It's because it's got to serve a reliable source of data to everyone in that vicinity. So it's not just something you can set up and over a matter of weeks. So we've talked about geography, and now I'm going to just zoom in a bit on what Cloudflare referred to as AWS egregious egress. So this is how much they estimate Amazon is marking up costs for you fetching files from S3. So Cloudflare estimate that it's costing, it's an 8,000% markup if what a company pays for retrievals from their S3 bucket compared to what AWS is paying to actually serve that retrieval, which is a big markup. And you can see down at the bottom here, it's smaller in these newer regions of AWS, but as they bed themselves in, they'll start to be able to create much more towards this ATX figure. So that kind of sets the scene of some flaws, I guess, with Web2 CDNs. I think the other thing to mention is just we're here to talk about Web3. We're here to talk about decentralized web. And so philosophically, I think if we want to build an end-to-end Web3 stack, the CDN is also going to have to become Web3 and decentralized. And that's also what we're focusing on here. So that brings us to this vision of the Filecoin retrieval market. And that vision is to build the world's best CDN by leveraging Web3 technologies. The first step in this process is just to try and get feature parity in terms of performance, cost, reliability with a Web2 CDN. And then the second step, I guess, would be to try and leverage the constructs and properties of content addressable data in a Web3 to perhaps outperform traditional CDNs in certain ways. So I'm going to go through a few of these now. First thing I've already mentioned, content addressable nature of the data. I believe that would have come up earlier in this hackathon demo day presentation. Instead of looking for the location of a file like a location addressed Web2 request, you're looking for, you say, I've got this CID and I'm looking to find the data for this CID. So if we look at this Web2 diagram, and let's imagine we've got 100 people sitting in an office, all trying to fetch the same video for a presentation that they're about to watch as a group, then they're all going to be making a request to this point, a point of presence, as they're trying to fetch that data from a location. Whereas in a content addressable setup, perhaps one person fetches it from a point of presence outside that office, and then others can start to share content in a peer-to-peer CDN with each other, saving a lot of bandwidth and a lot of internet requests and traffic by just sharing stuff inside last mile, like LAN network. Second thing is deduplication, which I think would have come up earlier as well. So let's say 100 companies all store the same file in an S3 bucket and therefore in a CDN layer on top of that. Then, if that's a hot bit of content, then people are going to be requesting it from all of these different endpoints, all these different locations. But using content addressing, we can deduplicate that, and a point of presence could store that file once, or perhaps we can replicate it enough times to make sure that the performance of the network isn't compromised, but not have it appear over and over again in the same points of presence. Permissionless. So I don't know if anyone remembers, there was an outage of Fastly in May last year, and vast swathes of the internet went offline. And that's because if you look at this sort of hub and spoke mechanism, if one of these green dots disappears, suddenly people aren't able to access data. They aren't able to get hold of data from that CDN. But if we move across to this sort of Web3 network, peer-to-peer CDN, if one green dot goes offline and we've got a good replication of data between these nodes, then we're able to fetch data in different ways from different nodes. So we can have more reliability in the network, even through outages. Verifiability, because we've got the CID and we're getting data back, we can actually verify that we're getting back the data we want. In the Web2 CDN model, we're actually trusting that the file we get back is what we wanted, but who knows, perhaps these Web2 cloud CDNs are tampering with the data, changing it slightly, reducing its quality. Who knows what's going on? But in this case, we can verify that we're getting exactly what we asked for. Also, as I mentioned earlier, points of presence, they're going to be a quite heavy weight to set one up for one of these Web2 companies. With a Web3 CDN, we'd really like it if people could join the network with just spare devices, with their phone, with old laptops, anything which they can then contribute to the network to, they can earn Filecoin for the privilege of being part of this network. And we can connect up devices of all sizes, and this allows us to get into geographies which perhaps Web2 CDNs aren't able to. Crypto incentivized, as we've seen, if you set up a kind of crypto mechanism design system, people do tend to want to get involved. There's also the caveat that people will try and game the system. So any crypto incentives to build these networks, we'll have to make sure it's done in the right way and is incentivizing people to actually provide a really good CDN service rather than anything else. Market oriented, we hope that where there's a desire for hot content, nodes will spring up and people will start to provide content for retrievals in those areas based on just the market. And this is also, I would say, a market for different products we built on top of the underlying retrieval market protocol. So would love to see an emergence of new ideas and technologies and products which grow out of this Web3 CDN vision. And then finally, smart redistribution of content. We hope that perhaps if files become hot in some area, that these nodes are going to be able to share with each other. Checking, no chat or hands up so far, so it sounds like we're all good. Cool, so that's the end of the motivation. We've gone through like some of the stuff about Web2 CDNs and where we could perhaps provide a better service. And we've spoken about what the vision is for a Web3 Filecoin retrieval market. Oh, this is a bit blurry, excuse me. We're now going to speak about where we are now. So we've looked at the big vision. I don't know how familiar everyone is with the Filecoin network, but here I've got in this diagram, very simply, we've got storage providers on the right-hand side. Storage providers exist in the Filecoin network and they are storing files and they're earning block rewards for storing those files. But of course, we need to be able to retrieve those files from storage providers. And at the moment, at Filecoin launch, the way that one had to retrieve a file was actually quite a heavy lift. As a retrieval client, this blue node on the left, you had to be able to set up a payment channel on the blockchain with the storage provider. And once you'd done that, you had to wait for finality for that payment channel. You would then be able to exchange vouchers for bytes of the file you wanted to retrieve in an optimistic fair exchange protocol. So this optimistic fair exchange means that the retrieval client would send, say, one voucher in exchange for 1 byte. And if the storage provider gave them that byte, they'd maybe send 2 vouchers for 2 bytes and then 4 for 4, building up trust between these two nodes which don't trust each other initially. And the reason it's optimistic is that at any point, the retrieval client could send some vouchers and the storage provider could just not return those bytes, and there's then no way to ensure that the whole file is transferred. With the way that Filecoin works, there's a protocol called GraphSync, which is used for this transfer, and the retrieval client can incrementally verify the file they're receiving to make sure that the storage provider is giving them the right bytes, even from the word go, which is really cool. And then after this whole exchange has taken place, the storage provider can redeem the vouchers that it's received for Filecoin against the network. One more thing to mention is like why are we doing all of this off chain? It's because if the retrieval client actually sent Filecoin to the storage provider, then it would be a transaction on the ledger, and we'd have to wait for finality of that, which would take a lot of time. So this whole mechanism of setting up a payment channel and then redeeming vouchers is so we can do very quick vouchers for bytes in an off-chain setting before redeeming vouchers at the end. So that was where we are after launch. Launching in March, there's an addition to this network, which is the indexer node. So one more thing to mention on this one is that the retrieval client also has to know where a file is stored. And this kind of departs from the IPFS approach, where you can use BitSwap to ask lots of different nodes whether they have a file, and then they'll ask nodes, and you've got that approach, that kind of gossip mechanism to find a file. In this initial Filecoin launch, you had to know exactly which storage provider was storing a particular file. But launching in March, we have this indexer node joining the network, where a retrieval client can ask the indexer node which storage provider has a CID, and the indexer node will tell the retrieval client, and then they can do the process as we've seen before. So we've got some measure of content discovery coming into the network. As we'll see later, there's other sorts of indexing which we're looking at, like content indexing. So how can we retrieve all files which are to do with cats? That's something which is not yet possible, and with something we're looking at in the retrieval market working group. This one, okay, it's starting to get a bit more hectic, these diagrams. We can see over on the right-hand side, we've got the storage providers we've spoken about and the indexer node. What we're looking to launch in 2022 is a whole new layer of retrieval providers, which are going to be lightweight nodes, as we've said, like mobile phones or people's spare desktops or laptops, which can sit close to the edge and provide retrievals for browsers and other clients. So there's suddenly, if we go back to here, there's quite a lot of, it's quite a heavy lift to be one of these clients. You have to be able to do graph sync. You have to be able to set up a payment channel. Here, we want to move to a point where these retrieval clients can be browsers, and we can make HTTP requests for car files, which is a contented archive file. And then the graph sync could happen behind the scene. There's also ways we could try and get graph sync into the browser that we're looking at, and I'll touch more on that later. But I won't go into too much depth on this here. Just doing a time check. Okay. So yeah, this is the direction we're heading. We've got the storage provider layer indexing, and then we've got this retrieval providing layer, which is starting to put content closer to the edge. These have points of presence all around the world, and in many, and close to the user, and then taking responsibilities away from our retrieval client in terms of what it needs to be able to do. A browser likes talking in HTTP and can just about talk in graph sync if we start to go into the service worker and stuff, but that's a heavier lift. So, these retrieval providers are trying to almost provide an interface between our entry points to the internet, which is essentially the browser, and the protocol labs protocols like graph sync. Cool. Right, and now, so that's I've gone kind of through where we are now, and I'm now just going to talk through like end-to-end example just to try and pull all this together, because I appreciate there's a lot of things going on here. So yeah, let's take, for example, Sarah, who has minted an NFT, and she lists it on Nifty Bazaar and NFT Marketplace. Nifty Bazaar then upload this NFT media file, let's say it's a 4K video, onto nft.storage. And nft.storage stored on a storage provider, and they also will make it available in the retrieval network or the IPFS gateway, and a few other ways for you to actually retrieve the file. But yeah, it's essentially stored as a content address file on the IPFS network, or on the Filecoin network, which means we can put that into the NFT metadata and have that immutable link between the content and the NFT. Now, Nifty Bazaar has got a lot of users in Sweden, and they would like to make this NFT media file instantly retrievable to users so that they can maximize the chance of Sarah being able to sell her NFT. And Sven, who lives in the very north of Sweden in a very remote area, has just visited the Nifty Bazaar website. Sven clicks on this NFT and he initiates a browser retrieval. And so that's what we spoke about in those previous slides, the ability to fetch a file from a retrieval provider from your browser. He can send one to a nearby retrieval provider, someone who's spun something up in North Sweden. And the quickest win is if that retrieval provider is caching the file and can immediately return it to Sven. It's a very quick retrieval. In the case that the retrieval provider doesn't have it in its cache, a cache miss, they can use that flow talking to the indexer node to find out which storage provider might have that file, and then do that optimistic fair exchange protocol with storage providers and get the file back into his browser. I won't go too much into reputation here, but there's also, because everything's decentralized, even the indexer and the retrieval providers, we need to know how trustworthy they are, and if they provided a good service before. So there'll be reputation systems that will be sort of taking account of what's happening in the network and giving scores to each of these different providers so that we can get a measure of which ones are the best ones to talk to. And that goes for the storage providers as well down the line. Whoops. So the indexer might, before returning to the retrieval provider, which storage provider to look up the file from, might just cross-reference it with some reputation scores. So yeah, the files made it back to Sven. Then there's, of course, the payment mechanism. So everything is decentralized in this network. And one of the big areas of research in retrieval markets is who pays whom and how that payment happens. Does it happen in protocol? Does it happen as more of a sort of out-of-band monthly payment? That sort of thing. So in these diagrams, it kind of shows that Sven's going to be paying for a retrieval from his browser, which kind of makes sense if it's, let's say, a Netflix model where it's like all the content's coming inside an application and you're happy to pay for let's say a 4K video. But if it's kind of a website approach, then you're going to be less happy to be paying for each retrieval of a file. And in that case, it might be that the payments are coming from the marketplace, and then even from the content providers to that marketplace. So there's loads of really interesting ideas that are forming around how we can do payment channels and how we can then resolve those payments against the Filecoin network once they've all taken place. Cool. So yeah, gone through retrieval markets so far. I see there's no comments or hands raised, so I'll continue on through. Yeah, we've spoken about retrieval markets, what it is, motivated the idea. We've spoken about where we are now, where we were at the Filecoin launch, what's coming soon. And then we've gone through this kind of example flow of what it might look like when we've got that future state sorted. I'm now going to speak about the retrieval market working group, which is the ecosystem teams who are working in this space on a day-to-day basis. The areas that the retrieval market working group focus on, and potentially could be areas of focus for those looking for something to work on in a hackathon, are the crypto economics of the retrieval market. That's something I just spoke about then, with how we can sort out these off-chain payments, but also looking at number two, potential block rewards for retrievals. There may be ways we could have sort of probabilistic payment lotteries where if you can prove that you've served a certain number of retrievals, potentially you could win block rewards for having done so. That's very much on the scale on the left. R is research, and then the bigger the letter, the more it is of research or development, essentially. We've got, so yeah, off-chain payment channels. I'll speak in a bit about a company which is doing some really interesting stuff there. Oops. Reputation systems we've spoken about, indexing, content indexing. We've got data transport and data transfer protocols. So looking at GraphSync, at BitSwap, at a combination of Filecoin and IPFS. It's what we call IPFS Filecoin interop, and what protocols that would involve in order to improve retrievals. Browser retrievals, as I said, the browser isn't that compatible with the underlying IPFS and Filecoin protocols, BitSwap and GraphSync. So how do we make browsers closer to the network? And then we look as well at kind of analytics of these networks as well. So just time check, I'm going to speak for another 5 or so minutes. I'm just going to run through a few examples of teams working in the Retrieval Market Working Group and what they're working on. So the first one is Myel. Myel, if you want to go to the website, it's myel.network. Myel is creating a decentralized content delivery network, scalable and peer-to-peer to suit the long-term needs of Web3 applications. In particular, they focused on the Myel Pop node, which is a retrieval optimized libp2p node. And they've also focused on Myel.js, which is some code which sits in a service worker of a browser and then allows you to do graph sync between a browser and a Myel Pop node in JavaScript. They looked into this and made some great progress and deployed a version of JS graph sync, but they wanted to go even further and they weren't quite happy with like the performance they were getting out of JS graph sync. So they're now working on Rust graph sync, and Rust graph sync can also exist in the browser because you can compile that Rust to WASM and then use that in the browser. And they're seeing some big performance gains in that case. So they're really focusing on this link between the browser and the first line of the CDN, of this point to presence, and some really interesting stuff coming out of their research. And I encourage everyone to have a look at their GitHub or their website to find out more. Or just get in touch with me and I can put you in touch with people who work at Myel. Second one I want to talk about is Magmo. So earlier on, we saw a payment channel that was created between a retrieval client and a storage provider. The problem with having a payment channel between every retrieval client and storage provider is that as the network scales, you have an awful lot of payment channels, particularly if it starts to become a peer-to-peer network where you need to have payment channels between every single pair of nodes. And that sort of order of n squared payment channels. And also the payment channels are currently only unidirectional. So you'd have to have order of 2 n squared channels in order to cover everything. So a company called Magmo, who they work on state channels. They've done loads of work with the Ethereum Foundation. They are now working on a payment channel manager, which essentially allows every node to just connect a payment or to make a payment channel with this sort of bank node or payment channel manager. And then the payments are resolved over 2 steps. There can be multiple of these payment channel managers, just like in the real world, we have lots of banks, but it means that we can really reduce the number of payment channels in the network because it would, this now scales sort of order of n rather than order of n squared, which is pretty cool. Chain Safe, they're working on content indexing, the IPLD web. Basically, can we have a Google search bar where you type something in and it returns all the stuff in the IPLD or stored on Filecoin or IPFS that is relevant to that Google search term. And they're also looking at other ways we can bring the browser closer to the network, looking at WebRTC and how we can have like a decentralized WebRTC protocols. WebRTC in its current setup does have to have what's called a signaling server, which is a centralized entity. So we're looking at ways that we can do WebRTC without the signaling server, which is really cool. And then recently, Protocol Labs has launched Filecoin Saturn. The aim of Saturn is to serve NFT media files to an NFT marketplace with very low latency, just like the example we saw earlier. And then also grow the Filecoin community by trying to get as many of these retrieval providers or stations out into the Filecoin network and get people earning Filecoin for providing retrievals. And we're looking for distributed system engineers and full stack engineers to help out on this initiative, which is, super exciting. Loads of people working in this Retrieval Market Working Group. And in terms of a hackathon, there's loads of smaller tickets or tasks or ideas that sit in the heads or the GitHub repos of all of the people working in these teams. So feel free to reach out if it's of interest to you. And how to get involved. You can check out retrieval.market. It's the website which lists a lot of the projects going on. I need to update it with some of the latest stuff. There's also Retrieval Market Demo Days that happen every 2 weeks. If you're interested to hear from some of the teams, you can find us on Retrieval markets on Filecoin Slack. And yeah, there's also office hours where you can come chat to myself or others involved. Nice. Well, I think that's my half an hour of monologuing done. So I can now open it up to questions.
Patrick, thank you very much. Questions? Anyone wants to raise their hands for questions for Patrick? While we wait for other questions, I do have a question for you. As I was going through your presentation, so do you have or have you thought about any kind of incentivization in order to establish storage in areas where the density of storage is low? So by that I mean it's very likely that some of the storage is going to be more focused in some areas than others, China or other regions, while in effect you may end up with the same problem that current CDNs have, which is kind of in Central African Republic, there's no one kind of serving that. Are you thinking about kind of different incentives or dynamic pricing in order to incentivize storage in those areas, or is that something that is kind of too complex?
Yeah, great question. We definitely have been thinking about that. It's still in the research phase in terms of how people could prove that they are serving something from a sparsely populated geography. I think the best example in the space would be Helium, who they are able to prove they have essentially building like a network, a telephone network, where you can prove your geography by how far away you are from other nodes using radio waves. So there's some cool ideas like that which we could reach for, to try and incentivize people to spin up these nodes, these retrieval providers in sparsely populated areas. But yeah, very much in the research phase.
Fantastic. In terms of timeline, you're talking about kind of reaching feature parity with current CDNs and Web2 CDNs. Where are you in terms of time-wise from that?
So yeah, we hope to get to this year like an average time to first byte of well under a second. So I think sometime in 2023 in terms of performance. In terms of reliability, that's a difficult one to measure because a Web2 CDN, they're able to control exactly the uptime and SLAs they need to reach. Whereas in our case, it's a decentralized network. So providing the reliability guarantees will be much more about how we can ensure content is replicated amongst different points of presence. And there is always a route for you to find content, even if nodes are going offline. So that's a very different problem in terms of reliability. We hope we could start to compete in that area, I suppose, 2023 as well. And then price, that will come down to the economic model that we reach for. And again, I hope that we can compete there because as we've seen, S3 are charging a lot for the egress fees. I think Cloudflare have come up with R2, if anyone's heard of that, which is trying to compete against these outrageous egress fees of S3. So to match R2's cost might be quite difficult. But then we have to remember that this is Web3 and people may be happy to, there are things people might be more happy to bend on if it's for a completely decentralized setting. Because it's worth remembering that these Web2 CDNs, they are the front line of the internet, and say Cloudflare is dealing with trillions of requests a day and logging all of that activity. They have an incredible knowledge base and kind of role and responsibility in the internet. And is that something we want we want to have in the internet of tomorrow? Just
a follow-up question from there, and since you mentioned Cloudflare, As we both know, Cloudflare has made quite an impact in the world of CDNs, and they've been very innovative when it comes to kind of implementing new protocols and new ways of doing things. Is there a world where the solution for the CDN kind of problem is kind of an hybrid one, where you have kind of maybe Cloudflare doing part of the work on top of a retrieval market, or the other way around? Is there a vision for that?
Yeah, I mean, in all the conversations we have, using Cloudflare comes up quite a lot, and a few of our ecosystem teams do use Cloudflare for certain things, but not other things. So it depends what you're trying to optimize for. If you're trying to solve one particular problem, it can quite often be helpful to use Cloudflare as a crutch to then solve this problem. But we do try in general to not lean too much on Web2 CDNs when trying to build a CDN, because it would undermine the whole process. Of course. Having said that, they are very useful for a lot of things.
Of course. Any other questions from our participants? Don't be shy. If not, Patrick, anything else you'd like to talk about?
No, all good. I just hope everyone's having a nice day and enjoying the presentations. And yeah, thank you very much for having me.
Thank you for your time. Thank you for the presentation. That was it was really great. So we're now going for another break. We'll be back in 20 minutes. Okay. Thank you, everyone.
Cool. Thanks. Bye.
Thank you, Patrick.